Hello everyone and welcome to this session here. Today we're going to have a look at multi-temporal NDVI change detection. So overall we're going to have a look at change detection of single raster layers, and we are following a multi-temporal approach, which means that we in our case going to have 4 time steps for Landsat 8 images. You actually can scale it up. The rule set that you're going to get is scalable, so if you have 400 images, that's gonna work fine. And then we're simply gonna compare the NDVI layers that we've created, that we're gonna create between each time step, and then we're gonna have our change. So that's the workflow. We first gonna create a customized import that only loads red and NIR bands from the original raw data folders of Landsat 8. So if you download Landsat 8, you unzip it and then you get a folder with multiple files, but we only wanna load or create projects that hold the red and near infrared bands. And using the customized import creates for each file or for each Landsat tile a project. Then in our case, we're gonna have 4 projects, and we then gonna create a rule set that computes the NDVI and exports the NDVI for each single project. So we're gonna create a rule set and we're gonna use batch processing. If you have a server license, then that's gonna work easily. If you don't have a server license, it's also gonna work. In this case, you're gonna need to invest a bit more manual work, but that's gonna be just fine. And then we're gonna create one single project with all those exported NDVI layers. We're also gonna create a customized import because I wanna have the layer aliases reflecting the name of the NDVI file. And the NDVI file is gonna have the date in it. So we're gonna export it in step 2 with the date as name. So number 4, create change layer between all time steps. Then, yep, that's what we wanna detect. We wanna do change detection. And what we're gonna do is we're gonna compute the change between T1 and T2, T2, T3, T3, T4 in our case. Again, if you have 100 files, that's gonna work as well. I'm gonna show you an approach with arrays and loops, and that's gonna be just working smoothly. Finally, we're gonna create hexagon objects and classify them. So we're gonna classify negative change, no change, and positive change. And finally, we're gonna export the results as a shapefile. So you're gonna have all the attributes in the attribute table in a shapefile. Alright, so first step is creating those projects for each tile, for each time step. We want to have one project and only the red and near infrared band should be loaded. After this session here, you can download any Landsat data that you like and test it as well. But in this case, we're going to stick to the data sets that I'm going to provide you. In the data folder, you're going to find 3 subfolders: customized import data and rule set RS. In the data folder, you already have the unzipped, so 4 unzipped Landsat 8 folders and one shapefile, which is representing the outlines, the land outlines of our area of interest. So that's gonna come in handy at the end. And yeah, let's have a look. So the date is here 2017, 2019, 2021, and here a very short period actually. But this one is very interesting because we currently still have a lot of fires in Greece, and you see a lot of changes, negative changes here of those burned areas. And let's open a folder, and that's what you get when you download Landsat 8 data and unzip the folder. You're gonna get multiple files, and actually we are only interested in this one and this one. So B4 is red and B5 is near infrared for Landsat 8. And we're gonna create a customized import that only loads those. So it looks into each folder here and looks for band 4 and 5 and creates a project. Then it goes into the next folder, looks for band 4 and 5, creates a project, and so on. Yeah, let's have a look at the customized import. I created it already for you, so you don't need to do anything. We also have a video on customized import, so have a look at our YouTube channel or in our community. Right click in the workspace, customized import. You simply can hit the load button and navigate to the data folder. and you're gonna find a customized import folder. We have two customized imports. First one is this one, L8 import only red and NIR. It's an XML file. Open that one. And you see that the search string has changed. It looks complicated, but again, watch the video and then it's gonna make sense. What you need to do is define the root folder. That's the root folder for the data. Simply select the data folder. And then you have to select one master file. And I'm gonna select the first B4 TIFF band. Hit OK. Now if you hit test, you see that something is going on, and that should do the trick. Before you hit OK, you can save this customized import, and if you save it in this directory, app data, roaming, eCognition, then the version number import, you're gonna find a few XML files if you have already created customized imports, but you simply can save it there and then hit instead of OK. So you can hit OK here and it's going to create those projects. Quickly going to do it. But if you save it in this default directory, you're going to have it also as a predefined import, which is very neat. Yeah, but let's have a look first at those. So how I set up the customized import is that the project name is the date, and it loads only layer 3 and 4 and 5. Let's have a look at the source view. So you see here layer 1 is B4 and layer 2 is B5, and it does ignore all the rest, which is nice. So I'm gonna delete those. And quickly gonna show you in the customized import that. So here at the end, that's the trick. 4 and 5. So this one tells eCognition only to use TIFF files that end with a 4 or 5, and in our case that's gonna do the trick. Okay, if you have saved it here in this directory that I mentioned before, it's gonna be available as a predefined import. So if you right click here in the workspace, instead of customized import, you can choose predefined import. And then it's gonna pop up here in the list of the import templates. So we have some predefined ones, and if you save it in that app data directory, yours gonna pop up here as well. In my case, it's L8 import only red and NIR. Then you have to define the root folder. So in my case, it's the data folder, and hit OK, and that's gonna create them exactly the same as the customized import. So once you have set up a customized import, you can save it there, and then it's gonna be available as predefined import, and you don't have to change the settings in the customized import. So that's gonna work for all Landsat 8 folders that you have. Okay, that's our first step. All right, second step is to create the NDVI, compute it and export it. And we are simply gonna create a rule set here in the process tree. First, I'm gonna add a structural process, call it NDVI calculation and export. And now I'm gonna insert a child, and computing the NDVI is easy. We have an algorithm called index layer calculation. Choose this one, and you can choose different index layers. NDVI is pre-selected because that's probably the most popular one. Then you have to find the red layer. In our case, that's layer 1, and the near-infrared, that's layer 2. Leave the rest default. It's gonna create the output layer NDVI. Hit execute and see if that works. All right, so let's have a look at the NDVI layer, if that makes any sense. I'm quickly gonna change the equalization to false color rainbow. Now red means high values in the NDVI and blue low values. Adjusting the stretch quickly. 0 and 1. Okay, maybe 0 and 0.5. Oh yeah. Okay. So red areas correspond to high NDVI values. See here these agricultural areas, and here forest areas, and also here agricultural area. So the value range looks good. Water is close to 0. So that's what I was expecting. Again, NDVI is in between -1 and +1. So that's the value range. And now we've computed it. And now we can export our layer, export image. And we're gonna we're gonna export the NDVI. And here the export path, simply change, or I'm gonna remove the project version here at the end. I'm gonna leave the project name because the project name is the date, right? That's how we've imported those files and named the project based on the date of that file. And I'm gonna choose _NDVI, and that's gonna create a NDVI file, or export this NDVI file that we've computed in our workspace directory. It's gonna create a results folder, and in there it's gonna create a folder yet again with this name here, and then the file's gonna be called project name, which is in this case 20170730 _NDVI. Okay, I'm not gonna execute it. Or let's execute it. But I haven't saved the workspace yet. So let's first save the workspace, otherwise it's gonna copy or save it in the data directories. So in this case, it created a results folder in the directory of the input file. That's not what we want. So what I'm gonna do is I'm gonna go to File and choose Save Workspace As. And I'm gonna save the workspace directly in the data folder. And I'm gonna call it new workspace NDVI change detection. All right, and if you execute the whole thing now, well, I'm just gonna execute the export, and that should create in the workspace directory a results folder and export image folder, and there you have your NDVI. That looks good. I'm gonna quickly delete the results again. And now we're gonna go into production. We're gonna use this rule set and run it across all 4 projects. So what you need to do is right click here, save rule set as, and I'm gonna save it again in this data directory and call it NDVI calculation and export, something like that. Okay, if you don't have a server license, you need to open the first project, execute the whole thing, then open the next project, execute the whole thing, open the next project, execute the whole rule set. Yeah, if you have a server license, please make sure the server, or at least one, is running. So if you go to Tools, Manage Local Servers, make sure you enable at least one engine. And then you simply can select all the projects that you want to analyze, right click, analyze, and we're simply going to batch process all those projects instead of going into each project manually and executing the rule set. So we're gonna let eCognition do it. So leave that localhost 8186. You're gonna know what this is if you watch the video on batch processing. Now you have to select the right rule set, data, NDVI calculation and export. So that rule set that you see here in the background, and hit simply start. And that's now going to process all those projects using eCognition server. All right, now it's done. Let's have a look at the output. So in the workspace directory, in the results folder, export image, we should now have 40 files. And they are named based on the date. That looks awesome. Cool, so that's step number 2. All right, step number 3, we want to create one project now with all those NDVI files. And I also have a customized import. You also could use the predefined actually, but I wanted to have the layer aliases named based on the layer name, so I created a customized import. Again, right-click in the workspace, customized import. I'm gonna clear this here and load again the other customized import file in the customized import folder. And this one is called NDVI change detection. Open. All right, and it's fairly simple. The clue is, I'm going to show you that in a second. Define the root folder. In this case, it's not in the data folder. Now you have to navigate to, to the data, to the workspace folder. Right, the results. So I'm gonna select the results folder. They're gonna be in there, those NDVIs. Select a master file, so one file. I'm gonna take the first one. And now I can go to the image layers, and you see the alias is defined here as this layer variable, and the layer variable is this section, so it's the name of the file. And yeah, the project's gonna be called NDVI change, and it's going to load all four NDVI files, and the alias is going to be named after the file. And yeah, you can save it and store it in this app data directory, and then it's going to be available as a predefined import as well. In my case, I simply hit OK, and then we should get another project. Let's open this one. Yeah, and you see we have 4 files in here. Let me actually quickly adjust the stretch so it looks fancy. Okay, so I changed the stretch from 0 to 0.3, and now you see different colors. It looks very interesting, and that's actually a combination of different time steps and the NDVI value. So if we look into this red area, for example, let's display it like this. If we check the pixel value, you see red is 0.24. Then the second value is the green value, which is lower, and all the others are lower. So the first value that is displayed is here red, second is green, third is this first blue, and fourth is the fourth blue. And it looks red because the first value is the highest, and that's in the red channel. And that's the time step 1. So there has been probably some deforestation or maybe a fire. It's a large area here. And on the other hand, here this yellow one, you see we have a distinct decrease here from time step 2 to 3. So second and third value, there's a drop. First and second are fairly the same, but then we have a big drop in the NDVI. We're going to have a look at this in detail. Same is true here. So big difference between 2 and 3. What about blue? Yeah, blue has a jump in this case between 1 and 2, and also 2 and 3, right? Okay, let's have a look at this one. All right, this is also yellow. Okay, and because I've time step 3 and 4 in the blue band, this looks the same as the other yellow area, but we have a drop here between time step 3 and 4. If we change this to something like this, we should have different colors. Okay. So, and black is always low values, white is always high values, so equal values, and that's a very nice color or false color composite using the NDVI. And I'm also going to show you one with the difference layers. Also for vegetation, highly interesting and holds a lot of information of changes in agricultural areas. Okay, now the task is to create a change layer between all time steps. I'm gonna show you first how you simply can, or how in theory it works for 2 time steps, and then I'm gonna show you a bit more advanced rule set that you can actually use if you want to scale it and you have multiple time steps and don't want to do it manually, right? And that's the idea. You want to save time, right? So let's go here into the rule set development layout and let's try to create this change layer. Or I'm gonna explain you the concept based on one change layer. I'm gonna delete the rule set here and I'm gonna create a new rule set. Change detection maybe. And in principle, let's have a look at time step 1 and 2. So there have been quite a few changes, as you see. Time step 1 and 2. So in the red areas we have a drop, so vegetation decrease, I would say, or at least NDVI decrease. How to create such a difference layer, right? That's what you want to have, and then you simply can use the difference layer for your analysis. You can use the layer arithmetics. Yeah, this one allows you to create any output layer based on a formula. And in our case, what we want to do here is, now I have to do it manually, which is a bit a pain, but so I want to compute the second, so T2 minus T1. So we have the difference between those. And hold on, I'm not going to type it. I'm simply going to get it from here. Copy paste. So this layer minus the first one. And I'm gonna call the output T1 minus T1 to T2. It's T2 minus T1, but that's time step T1 to time step 2. And we're gonna change it to 32-bit float because we have float values as input as well. Execute this and then we should get a difference layer. Let's display that one. Okay, I'm gonna adjust the stretch. Let me go to false color. And now let's go to minus 0.1 and plus 0.1. Okay, now you see in blue we have a negative change between those time steps. If we use this composite, so first in red we have time step 1, green time step 2, and the change is in the blue channel. And there you see the last digit is the difference between those two. And again, if we display this in false color, blue indicates a negative change and red a positive, so that's vegetation increase, red, and blue means decrease. And here in the agricultural area you see there's a lot of going on, a lot of harvesting, I guess, and also areas where you have a lot of growth, and that's nice, right? And this difference layer, this change layer, is actually gonna serve as input for our change detection. And finally, what we want to do is we want to create some objects and classify those objects based on the change, right? And then export our results. So in theory, I'm going to show you what we're going to do. You might remember that I mentioned hexagon segmentation. If you go to our knowledge base, you enter hexagon segmentation, you're going to find that customized algorithm that you simply can download and then drag and drop into eCognition. So if you want to do a hexagon segmentation, you can develop your own rule set, or you're going to use the rule set that Dirk already created. You're also going to find it in the download folder, in the RS folder, hexagon segmentation. I unzipped it already here. So this DCP, simply drag and drop that. Then you're gonna get error message. That's because there's a difference in the versions, but that's gonna just be fine. Hit OK. And now, if you want to do a hexagon segmentation, simply append a new process and look for hexagon. That's now gonna pop up here. And you have simply two parameters actually, hexagon height in pixels and the level name. I'm gonna call the level 1 and leave the hexagon height as the default settings. Hit execute, and then you're gonna end up with nice hexagons. So this customized algorithm was developed by Dirk Tiede from the ZGIS in Salzburg in 2013. So it's quite an old piece of code, but it's still running smoothly, and it creates nice hexagons. There we go. So we have hexagons size of 100. You can play around with the size settings. And now the cool thing about computing this change layer is that we have this mean feature that we can display. And then we already have a heat map, more or less, of change or whatever. So under object features, image layers, mean, we should have the T1, T2. Simply double click that, and then those are going to be colorized in grayscale. If you check the checkbox down here, and then right click on the T1, T2 and choose update range, it's going to colorize it into blue to green, into this color scale. And you are able to change the upper and lower threshold here. So let's increase or adjust this a bit so it looks nicer. Okay, something like that. So that's gonna be the feature values that we're gonna use. In this case, green again, this means high values, and negative values are now displayed in blue. And negative means negative change, so vegetation decrease, and green means increase. Now to classify those objects, what we need to do, or what we can do, is use simply assign class and class filter none, just to show you how that works. And in the condition we have to use this mean T1 and then choose the operator. Let's say if you are smaller equal to minus 0.2, then we're gonna put you into class extreme negative. I actually don't know if we have that class. It's gonna be red. Okay. Yeah, we don't have that. Let's change it to 0.1. Okay, so if this is lower, I'm gonna define it as intense negative change. All right, and you see that we have some objects classified. Those are mostly misclassified objects. Here at the border, you would need to take care of those. Up here, that's fine. So this object has T1, T2 minus 0.11. Here it also looks very negative, but this is minus 0.09. So it doesn't fall into that category. Close, but yeah, that's how it is. In the final rule set I'm going to show you, I'm going to take care of all these border effects and the background stuff like that. So just bear with me. I'm just going to show you that here in theory. Now let's create just a few more classes and say, all right, if you're unclassified this time, I just copy and paste the first one, and I'm changing the threshold here to 0.01 and set the class field to unclassified, otherwise it will also reclassify my already classified objects. And I'm gonna call this class negative change. And let's choose another color, this one, execute. All right, so that already looks like something. I'm gonna copy and paste the next one, again unclassified, and now we're gonna start from the other way round. So positive 0.1, if it's greater than that, it's a extreme positive change. Extreme positive is very green, of course. Hit execute. Border effects, never mind. And now copy and paste this again. Decrease. So those thresholds are made up by myself, but they give us nice results here. And this one is not that green. Positive change. Okay, and all the rest, So we have everything below 0.01 is somehow negative change, and everything above 0.01 is positive change. And now all the rest, let's copy and paste this one. All the rest, I'm gonna remove the conditions. All the unclassifieds are now no change, no change. Let's change the outline color to black. Okay, I'm gonna split the view and display only the classification on top. And now here at the bottom again, the false color rainbow. Yep, okay. And I want to have the swipe view. Let's have a look if this is meaningful somehow. Yeah, so the blue areas again are negative change, so they should pop up somehow in the classification as this orange or red class. The red areas are green and yellow areas should be gray, so no change, close to 0. Yeah. And yeah, what you see here is some effects in water. That's tile from Greece, and I'd simply download the outline of Greece, of the land mass. And in the final rule set I'm gonna show you, we're gonna load this and exclude area, ocean area. And we also gonna add some rules that exclude the areas that are outside of our tile, so with no data. And then we're gonna have a nice classification. This is now done on one time step. How the hell would you apply it now on all, right? You could do it manually, right? Do the layer arithmetics, change it here from the time step 1 and 2 to 2 and 3, change the output layer name, then apply all those things again. But you can do it in an automated way. Like for 4 layers, it's not that much work if you do it manually, but imagine having 20 or 30. It would be nice to have this in a single rule set that works or adjusts automatically to the number of input files, okay? So what I will do is I simply gonna close this project and don't save the changes. So we have a clean project, and I'm gonna open it again, this NDVI change, and that's what we had when we created the customized import, right? I'm gonna switch again to the rule set development layout. All right, and now I'm gonna arrange the windows a bit. Yeah, looks actually good. And we're gonna load this rule set I've created previously. Right click in the process tree, load rule set, and now in the rule set folder RS, you're gonna have this change detection RS rule set. Simply open that one. And the hexagon segmentation is already in there, right? So when I created the rule set, I loaded this hexagon customized algorithm by Dirk. And if you save the rule set, it's gonna be stored there as well. And actually the idea here is to create an array with all the input layers and then compare automatically the first layer with the second with the third with the fourth, and so on. And this is scalable, right? If you load 20 layers, the array is just gonna be longer, and it's gonna hold all those 20 NDVI layers and compare all of those, right? But only consecutive layers, right? It doesn't compare time step 1, time step 5. The implementation is that it always compares 1, 2, 2, 3, 3, 4, and so on. In our case, we have 4 NDVI layers. That means we're gonna create 3 different layers and for our change detection. And yeah, to create an array, I use this update array algorithm here, and I write in all existing image layers. If you execute this, we can display it down here. And you see my array has 4 layers, right? I also create these variables. I'm gonna execute this as well. Counter before, counter after. That's somehow my approach to get the numbers finally in the output name of difference layer. And yeah, it automatically creates those strings for the output layer name, which means, as we did before, T1 minus T2, so T1 to T2 and T2 to T3. So that should be created automatically. Again, if you have 20 NDVI layers, you're gonna end up with at the end T19 to T20. Okay, and then I create a loop here, and it loops as long as there are 2 or more items in the array. So it stops looping until the array is empty. So I start with the whole array, and I always remove the first entry of the array after one loop. So I first compare entry 1 and 2, then I create the difference layer. After that loop, I'm gonna delete the first entry, which is our time step 1. And then again, the array only has 3 items. Then I compare item 1 and 2 again. Create difference layer, then kick out the first one. Then I'm left with the 2 last ones, compare those and kick out the first one. Then I'm left with 1 array item. And because I have the condition here, it only loops if I have 2 or more in my array. So more than 2, more or equal to 2 items in my array. And yeah, that's the reason then why it stops, because there's only 1 item left. And more or less I'm doing the same. I'm somehow working here with strings to create automatically the naming output. Have a look at it, and yeah, ask questions in the community or in the knowledge base. But it's actually the same as we did before. So let's have a look. Yep. Yeah, so maybe this one is important here. I'm using the condition here in this loop, and what I do first, I'm gonna create a layer variable with holding the first entry of my array, which is item 0. So index 0, that's the first layer, and it's gonna write this into this variable current before, and then I'm gonna use the index 1, so the second layer in my array, and write this into the current after. And those are now time step 1 and 2 that I want to compare. And in the arithmetics, I'm using this formula current after, so I use this minus the before, and that's gonna be my output arithmetics. And what I do then, I rename the arithmetics based on the string that I've created previously, and then we're gonna end up with T1 to T2 to T2 to T3 and so on. So let's simply execute this whole thing, and we should end up with 3 change layers. Awesome, and I have this update display in here, so it's gonna automatically update your display and display the last 3 layers. So you see T1, T2, to T2, T3, and T3, T4. And if you create a false color composite, you get this nice colorful combinations. Yeah, you can change that as you like. But they actually hold a lot of information and reveal a very nice the changes that you have between the time steps. Let's have a look at this green area. You see here we have a big change in T1, T2. This means, so this purple one, a big change in T2 to T3. What else do we have? All right, this normal here, yeah. There's a bigger change in T2 to T3, so overall it's a bit of purple. And yeah, here in the agricultural area, it's very distinct. So you see big positive change here in T2 to T3, and that means green is yeah, has a high value here compared to the other bands, and that's why it pops up here in green. Red, the other way around, it has a higher value, or very high value compared to the others in the red band. Cool. And now actually what you could do is you actually wouldn't need to actually classify it. I did it here. That's a bit of manual work. So what I do here is I do the hexagon segmentation, then I load actually the shapefile. Let's go step by step. So the idea here is to do the same as before, but exclude the no data area and also exclude the ocean. And let's have a look how this works. All right, and that's how the hexagons look like. We created tons of them. And then in the next step, right, the no data areas that you see here, those scene stripes and also the tile stripes. We do have areas here as well. So let me display the first 4 layers. And you see, in this case, at least one of those has -1 values, which are no data values. The black area is -1 for all of them, so no data for all of them. And the same is true here for the scene boundary, right? At least one of them has a -1, so no data value. And we actually want to exclude all of those potentially no data areas that are there in one of those time steps. So what I'm doing here is exactly the same as before. I create the array, so I update array and first clear everything, so the array is empty. As you see in my case here, there's one left. That's the last array item because we always deleted the first one. So if I clear it, it's empty, and then I update it again with all those input layers, so all the NDVI layers. And now I loop through this array. So look into this array, take the first item, put it into this variable underscore current. So that's the current image layer, which is taken from the array. And now do a multi-threshold segmentation, right? And use this current layer. Apply it on image objects that are unclassified. And what else is important? Minimum min object size means it doesn't create objects smaller than 100. And threshold is -1. Everything that is equal to -1 or lower will be put into the class no data, and everything above stays unclassified, right? So it looks at the first layer, it finds in the array, puts it into this variable current, executes this multi-threshold segmentation. Then, because I created a loop, it takes the second item. So all those 4 layers are used here, and it looks into the class unclassified and does the segmentation and classification in one step. Okay. So if you execute the loop, it applies this multi-threshold segmentation using all those NDVI layers, and then we should have the no data areas classified. Even though it's only no data in one time step, it's still no data, otherwise we would have misclassified objects in the next step. All right, now it's done. Let's have a look at the classification. So I already, in this case, gave the no data class a very intense color, and you see all those, we still have our objects, all those objects outside of our scene are now classified as no data, and also those stripes here. This is great. In the next step, we use create modify project to load a thematic layer. You might need to change the path here. In our case, it looks into the workspace directory and takes the file that is mentioned here. But you also can simply copy, so that's a file that's in the data folder, but you simply can copy and paste it into the workspace directory and then execute this one, and it's gonna work fine. Or you're gonna change the path here to the location of the file in the data folder. Okay, and after loading this shapefile, you're gonna have the outlines displayed here. Now it's in white. Let's go for red and increase the size. So, and in the next step, we simply use vector-based segmentation, and we're using this thematic layer 1. And then we want to classify areas or objects that do not overlap with our vector into the class ocean. And that's all the area that you see here. And afterwards, we're going to focus our classification of change on the land area. So assign class, classify everything that is not overlapping with the polygon into the class ocean. I'm going to change the color to an ocean color, blue. Here we go. And yeah, let's change the display. So that's ocean, that's no data, maybe change no data to black now. And the outline is black. So that looks nice. And now we merge no data and ocean. We still have small hexagon objects, right? If we execute this, it will merge all objects that are classified as no data into one no data object and all ocean objects into an ocean object. And then we should have left our hexagons on the landmass that we're going to use for the classification. All right. Here we go, and now we have this classify. So it's the same as we did before, what I showed you before. Actually, you wouldn't need to classify it here. You simply could export a vector and append the values, the change values, as a column. But to show you something here, I did exactly the same. So I'm using the feature, and that is the classification result, right, from T1 to T2. Extreme negative change here in red. And the same is here for T2, T3, and it should change automatically. So overall we have a negative change. Actually between T2 and T3 we have 2 years almost. So and also this one is July and this one is June. So that might explain those negative changes. It's 1 month earlier. And T3, T4, that's in the same year actually. It's just 1.5 month difference. And what you see here is extreme change, and I think that was the big fire in Greece that led to this extreme negative change here, which just happened a few weeks ago. Okay, now the next step is the export number 5. And what we have here is export vector layer. So we're going to export our level, new level. Our class filters, all the change classes that we've created. And I'm going to export it. I'm leaving this here default export path, and that means it's going to create a results folder in the workspace directory. And yeah, the attributes are here T1, T2, T2, T3, and T3, T4. So we're gonna have a polygon output vector layer with these attributes in the attribute table. And yeah, let's execute it and load it again in eCognition so we see how it looks like. And I'm simply using drag and drop. You're gonna find that file in the results folder in the workspace directory in results object shapes. So I loaded it, it's now thematic layer 2, and you see the outlines of our objects, so the hexagons, and we can now display the attribute table. If you right click here, thematic layer attribute table, I'm gonna move that bit to the side, right click, enlarge columns. That's thematic layer 1, and we can display thematic layer 2. That's the one that we've exported. If you right click here, you can choose enlarge columns, and then it's going to enlarge the column so you see what's going on. You actually can sort here the different columns, and if you click onto one, it's going to highlight that one in the view. So if you zoom in the view and then click around here, you're always gonna see the corresponding polygon. That looks great. Okay, so that's the workflow, and this also can be used if you have more than just those 4 time steps. You can download 20 also in a different area. It should work fine because it automatically adjusts to the input layers, and the naming should be fine as well. So simply try it with different data sets and see if all the workflow works for you. I showed you here the NDVI, right? But you can do it on band 3, band 4, any other index layer. For burned areas, it would make sense to compute the BR, the normalized burnt ratio, right? We also have that. So instead of computing the NDVI, you can simply choose in the index layer calculation algorithm the NBR, export it, create a project with all the NBRs, and then run this one, and you're gonna have the change of the NBR. So that's simply an image to image or index to index change detection approach that I showed you here. And also what I wanted to show you is here how you can scale it using arrays and make it transferable instead of manually typing in everything, all the names, and yeah, which is very error prone. And in this case, it's running automatically with the array and updates or creates the output layer names automatically. Right, so I'm gonna stop here. Have a look at it. It's great fun. It was a nice project, to be honest. And let us know what you think. Thank you very much, and goodbye.